Okay, so 1.13, we're going to talk about algebra a little bit. So we're going to start getting into some letters rather than numbers. We're going to call them variables, kind of like we did with ordered pairs. Okay. So as always, we'll start out with an example. So it says, Evan's working on a math homework with his friend Ryan. Evan says that he can cancel the 2's in 2 over 3 plus 7 over 2, but he isn't sure what's left. Ryan says he could divide the 2's off if the computation used multiplication, like 2/3 multiplied by 7 over 2, but not with addition as it is now. So who is right and why? So this one, what Evan's saying is that he just wants to cancel the 2 up here and the 2 over here, right? But obviously we can't do that with addition because we need to have like denominators. So we know that Evan is wrong because we need the like denominators. Like denominators. So Evan's wrong because we need the like denominators to be able to add numbers. But Ryan's saying that we can cancel those 2's. So what we can look at is that eventually when we multiply these, so if I combine those into one fraction, we'll have 2 times 7 over 2 times 3. Right? And then we can see that those 2's cancel, right? So that's what he's saying about canceling those 2's. So in this case, Ryan is right. Okay, so all we're doing is just kind of rearranging the fractions and seeing that they have a common factor of 2. So we can cancel that on the top and the bottom to get that simplified fraction of 7 over 3. Okay? All right. So we've kind of looked at like maybe one of the properties that we could have that maybe we could start in with some algebraic terms. If we had like some x's or some y's or some other letters, maybe if we had an x on the top and an x on the bottom, we could maybe cancel those, right? So, okay, but let's talk about some terms here. So this is going to be a little bit heavy on terms. So it says for algebraic terminology. So algebra is the branch of mathematics in which variables are used to represent numbers and numeric operations are generalized. So instead of being given a specific problem like this, we'll have some variables in there, like letters, and we're going to either solve for them or simplify them as much as we can. Okay? So a constant is a value that does not change, that is a number. So an example of a constant is like 1, 5, 3 over 2, negative 0.5, things like that. So numbers, okay? A term is a constant or a variable, or the product or quotient of constants or variables. Okay? So a term, it could be a constant. It could be a variable like x or y, right? So it can be a letter, a variable. Or it can be the product or quotient of those. So we can multiply these together and it's still a term. Or we can divide these and it's still a term. Okay? So the example that they give, 5m and 5m are all terms. So if a term consists of only a number, it is known as a constant term, right? So we're just combining these two definitions. And then in the term 5m, 5 and m are being multiplied, which makes them factors of 5m. So we can kind of split that up, saying that 5 and m are both factors of 5m. Okay, so since 5 is the numeric factor of the term, it is known as the coefficient of the term. So a coefficient is just the number in front of a variable. So if I have 3x, for example, my coefficient here is just 3. So my coefficient is just 3. It's just the number in front of the variable. Okay? Okay. And then we have an important distinction between expressions and equations. And the easiest way to think about this is if it has an equal sign. So if we have 3x equals 0. So if we have 3x equals 0, that's an equation. If we just have 3x, that is an expression. So the important part is if there's an equal sign, it's an equation. If there's no equal sign, it's an expression. Okay? So when we are dealing with equations, we are solving them. When we are dealing with expressions, we are simplifying them. Okay. All right. So one question I have, it says, is pi, the circumference around any circle divided by its diameter, a constant or a variable? So let me draw a circle really quick, and then we will talk about it. So draw a circle. Draw a circle here. That's not completely accurate, so I'll redraw it here. There we go. Okay, so we have a circle. Something like that. And pi, so this is just pi, pi. Maybe people have some flashbacks to maybe high school, if you remember learning about pi. So pi, it's just the circumference, so the circumference is just all the way around. It's the circumference divided by the diameter. So it's just circumference divided by the diameter. Okay? And the key thing about this is that it's around any circle. So it doesn't matter how big or how small our circle is, it'll always equal pi. So that just means that pi is a constant. It's a value that does not change. Right? So pi is a constant. Okay. All right. So on the next page, this one says, consider the expression 3x minus 12. There are two terms that are separated by a subtraction sign. So I already gave it away, but it says, is this an expression or equation? It's an expression because there's no equal sign. It's an expression. It says, how many terms are there? Well, there's one term, two terms. So this is a term, and this is a term. So 3x and 12y. It could also be a negative 12y as well if you want to include the minus sign. It's up to you. And then it says, how many coefficients are there and what are they? Well, there's two coefficients. It's 3 and 12. Or 3 and negative 12. Either one. Okay. So it says, to make it easier to recognize the factors of a term, you can insert multiplication dots. So 3 times x and 12 times y. Your factors are the things that make up that term, and then the same thing there. Okay. Objects that are separated by division are also considered factors, since any division calculation can be written as multiplication. So for an example, it says 15w over 4 is the same thing as 1/4 multiplied by 15w. Right? So another way that we can look at this 15w over 4 is 15w divided by 4, right? And we could just flip this 4, which you could look at as 4 over 1. So you could get 15w multiplied by 1 over 4. So we're just flipping the second fraction and multiplying it instead. Okay? Okay, so what are the factors of this? Well, it looks like my factors are 15w and 1/4, right? Because those are all being multiplied together. So I have 1/4, 15, and w. So that's all the factors that make up this term, since we're multiplying all those together. Okay, let's examine this equation. So I have negative 8x plus 1 equals 2x plus 6. So that's what my factors are. So if I look back up here, I have factors, these two things are being multiplied together, and these two things are being multiplied together, right? So let's look at that. So if I look at that, let's see. It looks like I'm multiplying negative 8 and x together. So those are factors. And what else am I multiplying together? Well, another one, I'm multiplying 2 and x together. So I'll just write negative 8x and 2. So we could write x again. Oh, sorry. We could write x again, but we don't have to because it's already in there, right? It's the same thing. They're both x's. Okay. Okay. And what other factors do we have? Do we have any other factors? Well, I don't see any multiplication or division left over, right? So we don't have to worry about that. Okay. So what are my, and I'm not going to worry about common terms. I think that was just from last semester. I'm not worried about that. So what are our constant terms? So what's constant in this up here? So my constant terms are the things without variables in front of them, right? So 1 and 6 in this case. Okay. Now I could say, if I was looking at this is an equation. What are my expressions in this equation? So my expressions in an equation are, all they are just everything to the left of the equal sign and everything to the right of the equal sign. So negative 8x plus 1 is one expression, and the other one is 2x plus 6. Alright, let's move on to the next page. So the next page, we have an expression, right? So we have this expression right here. It should just be one expression, sorry. So we have this expression here, and I want to identify parts of this over here, right? So I have 3 and y. So we're looking at this one right down here. And I want to know what role they play, or if they're factors, they're terms, constants, and so on, right? So I see that I'm multiplying these two together, right? And so these two are both factors of a single term, right? So what about the next one? So 3y and 4. So if we just look at 3y and 4, well, I can tell you right away that those are just terms, right? So this is a term, and this is a term. So these are terms. And what about 2 and 3? Well, if we look at those, it looks like we're just multiplying a constant to a variable, right? So 3 multiplied by y and 2 multiplied by z. So we could say that these are coefficients, because they're just the numbers multiplied in front of variables. And another term for coefficients, we could also say that they are factors, right? So either one is correct. So coefficients or factors. Okay. What about x and negative 1, right? So we have x and negative 1. Well, we could just say that those are just both terms, right? They're just like 3y and 4, right? So we're just subtracting those. So we could say that these are also terms. Okay. And then finally, the last one, it looks like 2z, x, and negative 1. So what are those? Well, we're just multiplying them all together, right? There's a bunch of multiplication happening. So that just means that these are factors. Okay? Okay. So recall from a previous lecture that exponents are just used to express repeated multiplication. So as an example, instead of writing 2 multiplied by itself 4 times, we can just write 2 to the 4th power. So it's just saying the factor of 2 is being repeated, and it's being repeated 4 times. Okay? So if we look at this 2 to the 4th, that big 2, we just call it the base, and 4 is just the exponent. Okay? All right, and then when we have an expression that only has whole number exponents, so that's important, it has to be a whole number, as in negative 27x to the 3rd, so that's a whole number, 12.5x, which is just x to the 1st power, plus some constant, we call this expression a polynomial. Okay? So polynomials have no numbers in the denominator and no variables under square roots. Okay? So an example of something that's not a polynomial for the denominators is maybe something like 1 over x. So that's not a polynomial. And something under a square root, so like the square root of x, that is not a polynomial either. Okay? So we have a few specific polynomials. So a monomial is a polynomial with one term, right? So an example of that would just be x, right? A binomial is a polynomial with 2 terms, so maybe x squared plus x, right? So there's 2 terms there. And then a trinomial is a polynomial with 3 terms, and they give you an example right there. So we have 4x squared plus 3x plus 5. Right? Okay, so now that we know those, let's try to identify some of these, right? Or I guess we have one more concept, rather. The degree of a polynomial in one variable is the highest exponent that appears on that variable in the polynomial. So the example from the last page, the polynomial only has one variable, x, right? And the highest exponent of x is 2, so that's this one right here. Therefore, the degree of the polynomial is 2. So you're just looking for the greatest power on a variable. Okay? So what about negative 7x? What is the degree of the polynomial? Well, that's just an x to the first, right? So the polynomial has a degree of 1. Okay? Whenever you have just a constant term, so just like 12, its degree is 0. Whenever you have a constant, so just a number. Okay? Okay, so let's go through some examples. Let's identify if the expression is a polynomial or not. If it is, identify if it's a monomial, binomial, trinomial, or none of these. And then we're going to identify the degree. Okay? And then if it's not a polynomial, we'll state why and explain. Okay? Okay, so if we look at this, it looks like I have two terms, right? So I would say this is a polynomial. Specifically a binomial, right? Because there's two terms. And it has a degree of 2, which is just our exponent 2, right? If we look at the next one, I see 3 terms, so it's a trinomial. And it has a degree of 2 again, right? That's squared. N squared is our biggest one, so we have a degree of 2. What about 4? Well, that's a monomial. There's just one term. And the highest degree is 0, right? So 12, its degree is 0. Any constant always has a degree of 0. The next one looks like it's just a polynomial, right? Because we have 4 terms, so we don't have a name for it. So it's a polynomial. In the highest degree here, it looks like it's 3. Okay. The next one is 3x to the 1.5 power. So this one, is this a polynomial? Well, if we go back and look at the last page, one thing that I made sure that I mentioned is that it has to be a whole number exponent, right? And 1.5 is not a whole number. So we know that this one is not a polynomial. So it's not a polynomial. And that's because the exponent is not a whole number. So the exponent is not a whole number. Okay. What about the next one then? So I say one term, and it looks like we have a whole power exponent, right? So this is a monomial, one term, and it has a degree of 3, right? Because it has the highest one is 3 for the exponent. Okay. So notice one thing on E. Notice that since it's not a polynomial, it does not have a degree. It has to be a whole number. Okay. So the next one, I see 2 terms, right? So that's a binomial. And I notice that the degree is 4 because that's the highest exponent. Okay. Then finally the last one. Okay, so let's go and look back at the last page really quick. So one more thing that I pointed out is that the polynomials have no variables in the denominator. So an example I gave is 1 over x. So if we look at that last one, we have an x in the denominator, right? So it's not a polynomial. And since it's not a polynomial, the reason being there is a variable in the denominator. And since it's not a polynomial, there is no degree.